Hey everyone, today's lesson is lesson 109 and it's on corresponding parts and similar figures. And we'll be looking at the difference when we're looking at maybe like two triangles or two quadrilaterals, for example. What does it mean when they're corresponding? And also, a term that's not up here but should be is the word congruent. And then also, what does it mean when they're similar? So they're both related math terms, but they mean something different. So we'll talk a little bit more about what those mean exactly. Let's go ahead and look at our learning targets for today. Our learning targets are to identify corresponding sides and the corresponding angles of two congruent figures, also to identify similar triangles and their corresponding angles and sides. And then lastly, we have identify similar rectangles and their corresponding angles and sides. Let's go ahead and move on, and I'm going to talk a little bit about this. So when we're looking at corresponding parts, I'm actually going to zoom out just a tiny bit here so that you can see the entire slide I want you to see. When we're talking about corresponding parts, we're meaning that those are the same. So if I say that if, for example, angle A corresponds with angle X, that means that those are the same. Let's break that down a little bit more. First of all, we have two triangles right here, you can see, and those triangles are congruent. So, you know what, I'm just going to grab my pen here, and I'm going to circle this word, congruent. That's really important. Congruent is a math term that means same size and same shape. Exactly the same. So when we're looking at congruent triangles like this, one of them might look like it's tipped on its side or that it's backwards, but these triangles actually are congruent, same size and same shape. So if we were to, for example, we have triangle ABC and triangle XYZ. If we look at triangle ABC, if we were to tip that on its back almost, let's see if I can draw this out. If we were to like tip it forward, and then also it looks like we need to reflect this. I think that's even what the notes say. So flip it. They would end up perfectly on top of each other. And you know what, honestly, it might help you to like draw this out, like flipped it up the right way just to see if things are congruent. Then you can really closely see which angles are congruent with each other. So for example, like it says down below, you can see that the corresponding parts would be in the same place. So that's where we see angle A corresponds to angle X, so kind of at the tip here, as well as angle B corresponds to angle Y, so down here, kind of at the base of the hypotenuse, and so forth. So just kind of by moving triangles around, or figures I should say around, you can really see where their corresponding parts line up. Moving on to looking at a little bit further at that word congruent. When triangles or other figures are congruent, it means that they have the same side lengths because they're the exact same shape and size, right? So if we know some information about this triangle here, some information about this triangle here, and we're told that they're congruent, we can just fill in the missing information. So we have to kind of imagine this triangle here being tipped back. Oop, that's not a very straight line. Sorry about that. Tipped back, if this were our 90-degree angle here, we can see that our base is 3. And our height is 4. It's kind of hard to draw with the mouse. Okay, and our height is 4. And so we're missing our hypotenuse in this one and missing our base in this one. Well, we already said our base is 3. And if these are congruent, well, then the base of this is 3. And if we're missing our hypotenuse here, but we have 1 here, if this one is 5, guess what? This one is 5. So now ultimately they're asking us, well, what's the perimeter of each? We need to add up our side lengths, and that's our perimeter. So maybe if I switch to my stylus pen, this will be easier. We have 4 plus 5 is 9, plus 3 more is 12. And if I write that here, 12, and it's inches. 12 inches. We don't need anything squared. We're not multiplying an area of any kind. Our answer is just 12 inches. Let's talk about similar figures now. Now here's a new term. Similar is related to our word congruent, but it just means same shape. It doesn't necessarily mean same size. So for example, let's take a look at these triangles here. You have 4 triangles to look at. If we were to talk about the word congruent, which we looked at in the previous slides, these 2 triangles here, to me, appear very congruent. Same size, same shape. But now there's a 3rd triangle here that is the same exact shape, just a different size, and that would be triangle 3. So if we're talking about the word similar, this one right here, triangle 3, is similar to 2 and 1 because it's the exact same shape. It looks the same, but just a different size. It's bigger. And then, of course, kind of at the bottom here, they're asking us, this is a picture straight from my teacher's manual, so it even has the answer right there, but that's fine. I still want to talk about this question. They're saying, can we reduce or enlarge in triangle 4 to make it match the other triangles in the diagram? So they're asking, is there anything we can do to triangle 4 to make it either similar or congruent to the other ones? And the answer is no. It's not similar to them. It's a different type of triangle. Triangles 1 through 3 are right triangles. This one is not. So another thing to know about similar figures, we have a couple of examples here to look at. I really kind of want to skim down. This I thought was really important. These 2 points right here. There are 2 important things for you to know about figures when they are similar. The first thing is corresponding angles of similar polygons are congruent. So that means we can have a tiny little triangle and then a similar triangle, meaning it's the same shape but bigger. And as long as we're told that those triangles are similar, their angles inside are congruent, which means exactly the same. So even if the triangle looks smaller and bigger, if we're told that they're similar, their angles inside are congruent. They are the same, no matter what. The second thing to know is that corresponding sides of similar polygons are proportional. So the word proportional doesn't mean the same, but it does mean that there will be a consistent ratio between the 2. It won't just be, one set of lengths here and then just random sets of length here. Basically, we're going to take that smaller figure and multiply it by a certain number of times bigger to get your bigger figure. It'll always be consistent with an exact ratio. We'll look at a little bit closer to see what I mean here. This example, I'm actually going to back up and look at this. This is an example regarding congruent angles of similar triangles. So we have a smaller triangle here, a larger one here. They're asking, these 2 triangles are similar, then what's the measure of angle A? Well, we have to kind of use our imagination here to tip this triangle up so that the base is on the bottom, and it looks like we also have to reflect it, so flip it over. I can see that angle A for this triangle is at the top, like straight up from my 90-degree angle, which means when I look at this triangle, this is the angle that corresponds with that. It's straight up from the 90-degree angle. If that angle is measure 30, then the measure of angle A would be 30. And that's basically what they've shown us right here. Let's talk a little bit more. Here's an example about the ratio of corresponding sides. So they're proportional. Let's look at these 2 rectangles really quick. Basically, this bigger rectangle, we have side length AB is 2 centimeters. The side length of EF is 1 centimeter. So that's where you're going to see this ratio of 2 to 1. And I don't know, you'll probably remember from class, I just dropped my pen, that I prefer to write ratios kind of like this, 2 to 1, although my decimal points aren't working right now. So this is probably a better option. Ratios can look a couple of different ways. I'm sorry, you guys, I can't do decimal points. So same thing, the corresponding side BC is a 4, FG is 2, so we go from 4 to 2 and reduce that down 2 to 1. So we're seeing that whatever we have for a length in this smaller rectangle here, if we multiply that times 2, that's how we're getting our lengths over here for our bigger rectangle. So if we had a length here or here, we can always multiply it to get our bigger one. And so when they're asking, How many times larger is your larger rectangle? It's a scale factor of 2 because we're multiplying by 2. So that's it, you guys. That's it for our notes. To me, these terms, it's a lot of vocabulary all in one lesson. If you need any clarification, I encourage you just to rewatch this video or go back and look at your notes. Otherwise, yeah, your homework assignment will be linked in Google Classroom. Thanks for watching. Have a great day.